Then you can find the force along x-axis, the component, the value with I cap will indicate the direction, amount of the force along x-axis, and that amount will indicate the value of the force along y-axis. Then you can find fx, you can find fy to find out the ax and ay. These are the accelerations along x-axis and along y-axis. And if you have acceleration, it is very easy to find the displacement along x-axis and y-axis. In that way, this is the position vector of the particle or object. Clear? Now go to the numbers 4, next one. After number 4, we will start a new chapter, that is friction. So let me do another one. Read the question very sincerely. A person of mass 50 kg stands on a weight machine, having on a weighing scale on a lift. Okay, if the lift is descending with a downward acceleration of 9 meters per second square, what should be the reading of the weighing scale? So if you have a weight machine inside a lift, and the lift is descending with a downward acceleration 9 meters per second square, then what should be the reading of the scale? That is, what should be the reading of the weight machine? Okay. So at first, I think very good. Some of you are already doing this problem. Okay. Let us check it, whether those who have already done, that they are correct or not. Very good. Aviraj, Sohadda, all of you are doing. Let me find the normal reaction. Shubhrapratim 5 kg. Okay. So at first, I think all of you have picked up the question. First of all, you write normal reaction. What should be the normal reaction? The normal reaction, capital R equal to. You know the formula of the normal reaction, capital R? The total weight, this is mg. Whenever the lift is at static, the total weight should be mg. Whenever it is moving down, very good, Shubhrapratim, it should be mg minus ma. What is A? A is the acceleration with which it is moving down. Now, this is a mg is what? How much mg is given as how much value? 50. Mg is what? 50. Small a is 9. So it will be 50 Newton. So this is the normal reaction. Whenever the object is lying on a weight machine and machine is falling down, the normal reaction at that moment is 50 Newton. Therefore, you are asked to find the reading of the weight machine. Therefore, the reading of the readout, the reading of the weight machine scale is reading of the scale is 50 is the normal reaction. 50 is the normal reaction. I think whenever it is falling down, the normal whatever the normal reaction it has, that reading should be shown by the weighing scale. So reading of the normal reaction should be 50 Newton. You directly write this in that way. Okay, 50 Newton. So if you have an acceleration in the downward direction, You are asked to if you are asked that a lift is moving down, in that case, the normal weight of the object, it has a 50 kg, and what is the weight of it? Its weight should be 50 into 9.8, or it may be 10. So in that case, whenever the lift is at static, the weight machine should show the reading as 500 Newton. But whenever it is falling down with acceleration something A, then this amount should be subtracted from that. And this is the normal reaction. So whenever I am applying a normal downward force 50 Newton, the upward force acting on me will also be the 50 Newton. So this is the upward force. That means I am applying a force in the downward direction as 50 Newton. Now, if I want how much weight, in some cases, it has been given in that way. Say, this is 50 Newton is the force. It is divided by acceleration. What the acceleration it has? What the acceleration it has? Whenever it is falling down, it's 10. Now multiplied by g. So that means result will be the same. Result will be the same.
Acceleration was 9.
Okay. So this is about the number 2. That is number 4. Now, let us start a new chapter, friction. Friction. The next day I will try to do some more numericals regarding this chapter, regarding the laws of motion. Okay. Now, this is a new chapter, friction. In a few books, the chapter friction is associated with the laws of motion. That's why I'm just trying to discuss it with the laws of motion chapter. What is friction? The first question may be asked in that way. What is friction? Now, the discussion may be, you can start the discussion in that way. Whenever you have an object, say you have an object in that way, and this is another one lying on the surface. So if you have an object lying on another object, whenever it will try to move, or not try to move, just lying, in that case we can consider that there may a very good contact between them. When the two surfaces come in contact, as the different substances are there, the molecules of those substances will try to attract each other. Due to that, they will remain close to each other, not slide. It will not slide very easily. If such type of surfaces are coming in contact, the molecules of two different surfaces will try to attract each other, which is called adhesive force. If the molecules of different substances are attracting each other, they are called adhesive force. Due to that adhesive force, the motion of the object will oppose over the another one. Again, if you have the molecules of the same substances, say like substance, just you take 2 drops of water, you have a surface on which you are just giving 2 drops of water. If they are connecting with each other, they will attract the molecules, the liquid drops will attract each other. It can be shown in case of mercury. If you have two mercury drops, and if you are able to make a contact with one and with another one, they will easily just fuse together. That means what? If such type of similar substances are come in contact with each other, molecules are tremendously attracting each other. This is called cohesive force. In that way, every substances, every objects, whenever they are coming with another one, the molecules of those substances will try to make a very good attraction force, try to apply a very good attraction force on each other. Due to that attraction force, they remain in contact. If you have to try to move, or if you try to remove one from another one, if you are trying to remove them from one another one, then you will find that you need a very little bit amount of force. Sometimes the force may be a greater one, sometimes the force may be very little amount of force. Okay, so this phenomenon, whenever we are trying to move one object to another one, we are feeling some opposing forces. We are experiencing some opposing force whenever we are trying to move over the another substance. That kind of force is called frictional force. So what is frictional force? Frictional force is the force acting between the two surfaces in contact. Whenever the two surfaces come in contact, molecules are attracting each other. There may be some ups and there may be some humps, there may be some irregularities. Those irregularities will make contact with each other and they will lock with each other. And if you are applying a particular amount of force, then you may be able, below that force, you may not be able to move them over the surface of another one. That phenomenon is called friction, and that force is called frictional force. So what is friction? Friction is the natural phenomenon which occurs between the two surfaces whenever they come in contact. Okay. Now, what is frictional force? What is frictional force? What is frictional force? So frictional force is the force acting between the two surfaces in contact against the applied force on it. Frictional force is the force acting between the two surfaces in contact against the applied force acting on it. That means if you have one surface like this, an object is lying on it, you are trying to move it in the forward direction in that way. Exactly at the two surfaces in contact, along the two surfaces in contact, there will be a force acting in the opposite direction. That force is called frictional force. So this is the applied force, and frictional force is exactly opposite to the applied force. And this force will act just along the surfaces, along the two surfaces in contact. Okay. So what is frictional force? Whenever an object is under a force, whenever an object lying on a surface is under a force, then along the two surfaces in contact, there will be a force acting opposite to the applied force. That force is called frictional force. So, what are the causes of friction? Explain the causes of friction. So as we come to know that whenever two surfaces are in contact, there may be a friction force. If you are applying a force on it, the frictional force will act opposite to that applied force. Now, what are the causes? The first cause we have already discussed. Whenever two surfaces come in contact, the molecules of the two surfaces will attract each other. Due to that intermolecular forces, the object will experience an opposition along the direction of the applied force. That is the one reason of frictional force. In that way, the frictional force will develop due to the intermolecular forces acting between the two surfaces in contact. Another is, whenever you are considering two surfaces coming to the contact with each other, so one is this surface, another is that surface. It looks that they are very smooth, but if, very good, Lokojit, if you are observing a macroscopic observation, then you will feel that no, these two surfaces are not very smooth as they are looking. The two surfaces belongs huge roughness. Here you can observe huge amount of roughness, and in this roughness they are trying to interlock. These two surfaces will try to interlock with each other. So whenever they will be interlocked, the two surfaces will be interlocked with each other, then you need more and more forces to move them. Okay, this kind of interlocking will generate or produce a particular amount of frictional force which will oppose the applied force, and try to resist at its own position or own state of position. So in that case, a frictional force will develop in the opposite direction of the applied force. So there are the two concepts regarding the causes of friction. One is, due to the roughness, there will be a frictional force developed between the two surfaces in contact. Due to that, the object will not move very easily. And another is, there is a modern concept. This is a intermolecular attraction acting between the two surfaces in contact. Will also be able to oppose the applied force to move the object along the direction of applied force. Okay, so these are the causes. Now, is there any kind of frictional force? Is there any difference of the forces, that is the frictional forces developing in between the two surfaces in contact? The answer will be yes. There are different types of frictional force. On the basis of the nature of the friction, the frictional force can be divided into different types. What are the different types of frictional force? What are the different types of frictional forces? Whenever the objects are in static, the frictional force developed and at that stage is called static frictional force. Very important. Whenever the objects are lying on the surface and the applied force is not able, Rohit, very good. When the object is lying on a surface and the applied force is not able to move the object, because I am applying a force of 1 Newton. That force is not able to move the object. Yes, Lokojit, very good. That means there is no relative motion still now. There is no relative motion developed. So 1 Newton force I am applying, 2 Newton force I am applying, 3 Newton force I am applying. these forces are not able to move the object in the forward direction. But whenever I am applying a force of 5 Newton, 5.1 Newton, then that force is able, just able to move the object in the forward direction, that is along the direction of frictional force. In that case, when the objects are in static condition, the applied force is not able to move the object along the direction of the applied force. The frictional force developed at that stage are called static frictional force. Now, 1 Newton force is not able to move the object, it is static. Then at that stage, 1 Newton force will develop here. I am applying 2 Newton, there is a 2 Newton frictional force developed already. 3 Newton, there is also developed a 3 Newton force, frictional force. 5 Newton, just now, I am feeling that I may be able to move the object, but I am not able just now. But I can feel it is yet to move. After 5 Newton, if I am applying 5.1 Newton force, then the object is moving. That means 5.1 Newton force is just able to move the object. Below that force, whatever the forces I am applying here, that forces are not able to move the object. That value of the force, that is the highest value of the static frictional force, which was able to resist the object in static condition, is called limiting frictional force. So what is limiting frictional force? The highest value of static frictional force, which can make the object in static condition, which can keep the object in static condition, is called limiting frictional force. The highest value of static frictional force that can able to resist the object in the static condition is called limiting frictional force. Okay, limiting frictional force. Then how, if just define me what is how you can define the limiting frictional force? Lokojit, can you define the limiting frictional force? Can you define the limiting frictional force?
So the highest value of static frictional force, which makes the object static in static position, is called limiting frictional force.
Okay, Aviraj, can you define what is static frictional force?
The frictional force which keeps the body in at a static position is known as the static frictional force.
Right. Very good. Now, if you are asked how the static frictional force changes their values with the applied force, how the static frictional forces changes their values with the applied force, what should be the graph? What should be the nature of the graph? The graph will be like this. This is the applied force. This is the frictional force. And definitely static frictional force is also under the frictional force. Then how the static frictional force changes with the applied force? If you are applying a force, then static frictional force is proportionally. Static frictional force will increase proportionally, like this. Static frictional force will increase proportionally. But the highest value of the static frictional force is separately named as limiting frictional force. This is the first kind of frictional force, static frictional force. Second, kinetic frictional force. Now I am applying a force 5.1 Newton, say. After that, the object is moving. If I am applying now 5.2 Newton, then the object will also will be in motion. 5.3, then the object will be also in motion. But very interesting fact is there. If you are applying now 5 Newton or 4.9 Newton force, then you can observe that still the object is in motion. Still the object is in motion. But previously, whenever you are applying 4.9 Newton force, in that case, the object was in static. After 5.1 Newton, the object becomes in motion. The object comes in motion. Now again, whenever I am applying 4.9 Newton, the object is still in motion. And no need to increase the applied force to keep the object in motion. If you are applying continuously 4.9 Newton, the object will be in motion. The object will be in motion like this. That means the graph will be like that. This is called kinetic frictional force. Kinetic frictional force. This is called limiting frictional force. And up to this, whatever the forces are acting, frictional forces are acting, these forces are called static frictional forces. Static frictional forces. Am I clear? So first frictional force was static. Very good, Saptajyoti. Second is kinetic. Third, what about the third frictional force? This is called rolling. Very good, Aviraj. Rolling frictional force. Now, scientists or people are thinking that whenever object is moving on the rough surface, horizontal surface, there is a huge frictional force. How we can decrease that amount of frictional force? If always there is a frictional force, then object will be always depreciation will be there. How we can use an object in a long way? Then they are trying to decrease it by giving a new shape. Okay, Rohan. Okay, by giving a new shape, it is a one kind of round shape. In that case, the frictional force, whatever the frictional force is acting, that frictional force during a motion of an object in a round way. Say object is giving a round shape, then whenever it is trying to move, there is a rolling frictional force, because a round object will always try to roll it. Whenever there is a rolling, the frictional force will decrease from that amount. That is called a rolling frictional force. So static frictional force one, kinetic frictional force another one. This is the third on rolling frictional force. In some books, you may get another frictional force. You may get another kind of frictional force, which is called, sometimes it is called rolling frictional force. If you are asked a rolling frictional force, what is rolling frictional force? This is this one. Sorry, I am telling you, in some books you will get a fluid frictional force. Fluid, not rolling. Kinetic, static, okay. Kinetic, okay. Rolling, okay. Whenever object is in round shape, it will experience a rolling frictional force. Now it is fluid frictional force. It is another kind of frictional force. Whenever object is trying to move through a fluid, the fluid will also apply a force on it. This is called fluid friction. So there are 4 types of frictional forces. 4 different types of frictional forces depending on the nature of the motion, depending on the shape of the objects. Clear? Next, the 5th question. Write down. 5th question. How frictional force changes with applied force. Show graphically. Show graphically. Argodeep, Annesha. Can anyone answer it? Can anyone give me the answer of this question? How frictional force will change with the applied force? Show graphically. What should be the answer? Abhay. Ananya. Udayan. Nilanjana Shah. Yes. This is the above graph. Yashraj is telling the answer is the above graph. Yes. This is the answer. Actually, I have written the question at the below. The answer is the above the question. Very important question. Very important answer. Simple. Up to the limiting friction, it will be a static. After that, whenever object is in motion, whenever the answer is in, when the object is in motion, then you need not apply the limiting amount of frictional force. Limiting frictional force, তোমার একটু little bit amount of force কম দিলেও then object will be in motion. একটু less amount of force apply করলো, then the object will be in motion. Clear? Very important question. So I think up to this is clear. Next, number 6. Number 6. What is the angle of friction? What is angle of friction? Now, if somebody asks me, what is angle of friction? What is this? Very interesting. You see, say you have an object lying on the surface. This is an object lying on the surface. You are applying a force on it. Definitely, a frictional force will develop exactly in the opposite direction of the applied force and along the two surfaces in contact. And this is the normal reaction. The normal reaction is along the upward direction. The frictional force is along the two surfaces in contact. If you drop a parallelogram, then the vector law will give you the idea about the resultant force. About the resultant force along the diagonal. Resultant force will along the diagonal, right? This resultant force makes an angle, something with the normal direction. That angle is called angle of friction. Angle of friction. So then you define the definition. How you can define, how you construct the definition. Shaptojyoti. Can you tell me the definition? Can you tell me the definition of angle?
Sir, the angle of friction may be defined as the angle which the resultant of the limiting friction and the normal reaction makes with the normal reaction.
Well, very good. Very good. So, how you can define the angle of friction in between, in case of two objects in contact, can be defined as the angle between the normal reaction and resultant of the normal reaction and frictional force. I'm telling again, the angle of friction is the angle between the normal reaction and the angle between the normal reaction and the resultant of whatever normal reaction and frictional force. Means normal reaction and frictional force, what the resultant they have, this and the normal reaction itself makes a particular angle which is called angle of friction. Very, very important. Okay, you may be asked in test of a question, maybe giving 1 mark, and you have to draw a simple drawing should be there, and you can define. If there are 2 marks, then you will get the full marks. I think it will come with 1 mark if it is given in the exam. So, what is angle of friction? I think it is very clear. Applied force, opposite direction, there is a frictional force, and normal reaction is there. Normal reaction is there. I'm standing here, so I'm applying a force on this bottom of my leg. So whenever I am keeping my foot on a particular surface, I am applying a force. There is a normal reaction in the opposite direction. That is also here, and the frictional force and normal reaction will give a particular resultant. That resultant inclines with normal reaction, which will give you the friction. Last, number 7, the last question. After that, we will leave the class. Last question. What is angle of repose? What is angle of repose? Say you have a inclined plane. An object is lying on it. Its situation is such that it is here to slide. It is here to slide. Anytime it can start its motion along the outward, but it is not here to move. That angle of inclination. Is called angle of repose. I'm just giving an example. Say you have a plane. And an object is lying here. If you incline it, still it is not moving. Just at this particular angle of inclination of this surface, the object just here to slide. That minimum value of the angle for which the object is just starts its motion, that angle is called angle of repose. Very good. Arpita, can you define now the angle of repose? Just tell me quickly how we can define the angle of repose from this definition. Those who can, you can raise your hand. Those who can tell me. Arpita, can you tell me? Krishita, tell me. What is the angle of repose?
It is the angle made by inclined surface with the horizontal at which any block kept on it will just show the tendency to slide down.
Okay, very good. It is the maximum angle of inclination up to which the object can just remain in static condition. और तुम यदि बोलो डेफिनेशन का रिवर्स करता हो, तुम्हें मिनिमम दिए बोलते पारो, मिनिमम दिए तुम्हें की भाई बोलते, शब्द तो जो दिया होगा बोलो. Rohan, you tell me.
Sir, it is the minimum angle that an inclined plane makes with the horizontal when a body placed on it just begins to slide down.
এভাবে বলা যায় that means a minimum angle at up to which a body can remain at static condition is called angle of repose. You see, this is the object, this is the weight, this is the component mg cos theta, sorry, mg cos phi. This angle is phi.
স্যার আগের ডিফারেন্সটা আর এখনের মিনিমামের ডিফারেন্সটার মধ্যে স্যার পার্থক্যটা কোথায়?
Actually, আমি যদি ওকে এরকম রাখি, অবজেক্ট এখানে স্ট্যাটিক থাকতে পারবে না। Now it is moving. I am just making inclination angle decreasing. Now this is the maximum inclination angle. এখানে পড়ে যেত এখানে রাখলে পড়ে না। ম্যাক্সিমাম ইনক্লিনেশন অ্যাঙ্গেল এইভাবে আমি ডেফিনেশন দিতে পারি। নাও আমি যদি বলি না আমি এখানে এইভাবে দেবো, এই অ্যাঙ্গেলে ইনক্লাইন থাকে, স্ট্যাটিক থাকে, দিস নাও স্টিল স্ট্যাটিক, নাও স্টিল ইট ইজ স্ট্যাটিক ইন কন্ডিশন, নাও ইট ইজ স্টিল ইন স্ট্যাটিক কন্ডিশন। নাও দ্য অবজেক্টিভ সাইড, দিস ইজ দ্য ম্যাক্সিমাম অ্যাঙ্গেল, এভাবে বলতে পারি। ঠিক আছে, ওই দিক থেকে আসলে আমি মিনিমাম করে দেবো, আর এই দিক থেকে আসলে ম্যাক্সিমাম করে দেবো। You can define it in both ways. Now, anyone can tell me what is the component of it, of the force along the inclined plane, which is the responsible amount? Which is the responsible amount?
স্যার mg sin,
right?
অ্যাঙ্গেল অফ রিপোজটা হবে mg sin phi.
Right. So it is mg. Shweta, very good. Jeffrey. Now, mg sin phi is the responsible force to move the object in a downward direction, right? And if there is a frictional force acting in the upward direction, F, if there is a frictional force acting in the upward direction, F, then F will be mg sin theta when the object is not falling down, the object is not sliding down. In that case, this is equal to this. Clear? So, in case of angle of repose, the frictional force should be equal to the mg sin phi, the force acting in the downward direction. Clear? And in the previous case, what we have discussed, this is the applied force, this is the frictional force, this is the normal reaction, and this is the resultant. This angle is called angle of repose. In that case, if you find tan theta equal to, this is base, this is normal. That means this is F, this is R. Tan theta equal to, this is F, that means this one is also F by R. Okay? Tan theta equal to F by R. You can write like this. Clear? This is angle of friction. Frictional force and angle of friction is this. Frictional force and angle of repose is this. In the next class, I will try to explain the laws of friction and relation between them, how you can prove it, and the rest of the discussion. I will try to do the rest of the discussion in the next day. We will finish the total discussion regarding friction in the next class. Till now, if you have any confusion, you may ask. Okay, Dibbendu, you have a problem regarding the limiting frictional force. Just you see what the static frictional force is. Whenever object is in static condition, say the object is lying here on this horizontal surface. You are applying a force in this way. The object is not moving because exactly in opposite direction, the same amount of frictional force has been developed. That's why you are not able to move it. If you are increasing your applied force, then the static frictional force developing along the two surfaces in contact in opposite direction will increase. In that way, this process will continue after a particular value of applied force. Now, static friction is not able to increase its value after that. This is the highest value up to which the static friction can develop its value. That means the static friction reaches its maximum value up to which the object remain in static condition. After that, whenever you are increasing your force, then the object will be in motion. So then the object will be in motion. That value of the highest frictional force, which was able to make the object or to keep the object static, is called limiting frictional force. That is, limiting frictional force is the highest value of the frictional force, which develops during the application of external force, jeta object ke static rakhte perechi. After that, the object will not be in static condition, because there will be a motion developed in the object. There will be a motion developed in the object, which will develop as a result of the kinetic frictional force. After that, there will be a kinetic frictional force developed in the two surfaces in contact whenever the object is in motion. So, highest value of the static frictional force is called limiting frictional force. Limiting frictional force is still able to make the object, to keep the object in static condition. Dipendra, clear? Any other question from your side? Okay. Yes, Saptajyoti, very good. This is the maximum static frictional force. Limiting friction is the maximum static frictional force. Then, okay, if you don't have any kind of query, then you may leave. Clear? Chalo, aajke chhadchi ekhane. The next hour, Monday, I try to send the video of this class, as we are taking the class in an odd time. Whenever Rohan, listen. Why Rohan is asking a question, very interesting question. He is asking that why limiting frictional force is greater than the kinetic frictional force. Actually, whenever two objects are in static, they will be very much comfortable to apply the intermolecular force acting between them. The intermolecular force will be comfortable to act between them whenever the objects are in static. But whenever there is a dynamic situation, whenever objects are trying to move on each other. So, is there any question? খুব ভালো করে দেখে রেখে আসবে। বিরাজ কেমন চলছে পড়াশোনা? We are taking the classes. Say I am taking this class. Whether you have read all these things previously, or I think maximum of you have done all these things. Is not it? Our baki ache je aajke this is the first time I have just come to know about friction. No, still now we don't have any kind of information regarding exam. Let us wait whether in December we are able to open this school or not. If government permits, department gives us the government allow the school authority to open the school, then we'll start the school classes. After that, we will try to take the exams. Acha. এখন যেটা বলছিলাম, whenever we are taking all these classes, try to cope up. Try to give a particular whatever the book you have. Try to see all the topic from the book. It will take 20 minutes to see all the topic from the book. And I think it will be better for you. মানে রিভিশনটা খুব ভালো হবে। রিভিশনটা খুব ভালো হবে। আগে যদি পড়েও থাকি, if you go through the just a 15 or 20 minutes revision, if you are able to give a 15 minutes revision or 20 minutes revision, that will be more beneficial for you. একটু দেখবে, হ্যাঁ, ঠিক আছে। তাহলে আজকে ছেড়ে দিই।